According to the National Electrical Code, NEC, Article 310.14, the paralleling of conductors is permitted for services and feeders, but there are crucial guidelines to follow. It is important to understand that the ampacity of the parallel conductors must be less than or equal to the ampacity of the single conductor that would be used without paralleling. Let's break this down further. Imagine a scenario with multiple runs of multi-conductor armored cable, such as 4 runs of 4-conductor 240 armored cable. This means a total of 16 conductors are available. If you are considering using 3 conductors from each cable to comprise a phase, you would effectively have 12 conductors in parallel for each phase. The question is whether this arrangement complies with the NEC. To determine compliance, we need to consider the ampacity of the conductors involved. The ampacity of a single 240 conductor is 280 amps, according to typical ampacity tables. Therefore, the combined ampacity of 12 such conductors in parallel would be 3,360 amps, calculated by multiplying 280 amps by 12. Now, the critical comparison comes into play. We must compare this combined ampacity of 3,360 amps to the ampacity of a single conductor that would be used if paralleling was not employed. If the 3,360 amps exceeds the ampacity of the single conductor alternative, then the paralleling arrangement is not permitted under the NEC. This is because the NEC aims to ensure that the overall ampacity of the parallel conductors does not exceed what a single, appropriately sized conductor could handle. This requirement is in place to prevent overloading and potential safety hazards. In addition to the overall ampacity limitation, NEC Article 392.8 D introduces another important restriction concerning the paralleling of conductors from different sources. This section specifically addresses situations where conductors from different cables or circuits are used to supply the same service. NEC Article 392.8 D states that conductors of a feeder or branch circuit supplying a service shall not be paralleled with conductors of another feeder or branch circuit supplying the same service. In simpler terms, this means that you cannot use conductors from different cables or circuits to create a single phase. The NEC intends to maintain the integrity of each feeder or branch circuit by preventing the mixing of conductors from separate sources. To illustrate this, consider the scenario of using conductors from multiple cables to create a single phase, as described earlier. In such a situation, where conductors from different cables are combined to form one phase, the arrangement is not permitted under the NEC. Instead, the NEC requires that each phase be comprised of conductors from a single cable or circuit. This ensures that the current flow within each phase is contained within a single source, maintaining proper circuit protection and coordination. In summary, when paralleling conductors, it is essential to adhere to the following guidelines. Firstly, ensure that the combined ampacity of the parallel conductors does not exceed the ampacity of a single conductor that could handle the load without paralleling. Secondly, avoid using conductors from different cables or circuits to create a single phase. Each phase should be supplied by conductors from a single source. By following these guidelines, you can ensure that your paralleling arrangements comply with the NEC and promote electrical safety. Let's delve deeper into the implications of NEC Article 310.14 regarding the paralleling of conductors. This article is not just a simple permission slip for paralleling, rather, it is a comprehensive set of rules designed to ensure safety and reliability in electrical installations. One of the key concepts to grasp is the idea that paralleling conductors is not a substitute for using appropriately sized conductors in the first place. The NEC prioritizes the use of a single conductor that is capable of carrying the required current. Paralleling is only permitted when certain conditions are met, typically when a single conductor becomes impractical due to size limitations or other engineering considerations. When considering paralleling conductors, it is crucial to assess the overall load requirements and determine the appropriate ampacity for the circuit. This involves calculating the total current that the circuit will be expected to carry under normal operating conditions, as well as accounting for any potential overloads or fault currents. Once the required ampacity is determined, You can then evaluate whether a single conductor is sufficient or if paralleling is necessary. If paralleling is deemed necessary, the next step is to select the appropriate conductors and determine the number of parallel runs. The NEC provides guidance on conductor selection, including considerations such as conductor material, insulation type, and temperature rating. The number of parallel runs will depend on the ampacity of the selected conductors and the overall ampacity requirement of the circuit. It is important to ensure that the parallel conductors are properly sized and installed to evenly distribute the current. This typically involves using conductors of the same size, material, and length, as well as ensuring that they are properly terminated and connected. In addition to conductor selection and installation, the NEC also addresses other important aspects of paralleling, such as overcurrent protection and grounding. Overcurrent protection devices, such as circuit breakers or fuses, must be properly sized and coordinated to protect the parallel conductors from overloads and short circuits. Grounding conductors must also be properly sized and connected to ensure a low impedance path for fault currents. Furthermore, the NEC may impose additional requirements depending on the specific application and the type of electrical system involved. For example, in some cases, it may be necessary to provide additional protection measures such as ground fault protection or surge protection. It is essential to consult the NEC and other relevant standards to ensure that all applicable requirements are met. Now let's explore the specific scenario involving 4 runs of 4-conductor 240 armored cable. In this case, the question arises whether it is permissible to use 3 conductors from each cable to comprise a phase, resulting in 12 conductors in parallel for each phase. As previously discussed, the NEC imposes limitations on the ampacity of parallel conductors and prohibits the mixing of conductors from different cables to create a single phase. Therefore, this arrangement would likely be considered a violation of the NEC. Instead, the NEC requires that each phase be comprised of conductors from a single cable or circuit. This ensures that the current flow within each phase is contained within a single source, maintaining proper circuit protection and coordination. In this scenario, the alternative would be to use a single cable with 4 conductors to create each phase. This would involve connecting all 4 conductors in parallel for each phase, ensuring that the combined ampacity of the 4 conductors is sufficient to carry the required current. It is important to note that even with this alternative arrangement, the ampacity limitations of NEC Article 310.14 still apply. The combined ampacity of the 4 parallel conductors must not exceed the ampacity of a single conductor that could handle the load without paralleling. In addition to the NEC requirements, it is also essential to consider other factors such as the physical constraints of the installation and the potential for voltage drop. Paralleling conductors can help reduce voltage drop, but it is important to ensure that the conductors are properly sized and installed to minimize this effect. It is also important to consider the physical space available for the installation, as paralleling conductors may require more space than using a single, larger conductor. In conclusion, paralleling conductors is a complex topic with numerous considerations. The NEC provides detailed guidance on the requirements for paralleling, including limitations on ampacity and restrictions on mixing conductors from different cables. It is essential to consult the NEC and other relevant standards to ensure that all applicable requirements are met. It is also important to consider other factors, such as voltage drop and physical constraints, to ensure that the paralleling arrangement is safe, reliable, and practical. Understanding these principles will lead to a safer electrical system. In order to have an even better grasp of this topic, let's discuss some additional aspects of paralleling conductors according to the NEC. The NEC provides specific guidelines on how to properly size and install parallel conductors. These guidelines are designed to ensure that the current is evenly distributed among the parallel conductors and that the overall installation is safe and reliable. Firstly, the NEC requires that parallel conductors be of the same length, material, and cross-sectional area. This helps to ensure that the impedance of each conductor is the same, which in turn helps to ensure that the current is evenly distributed. If the conductors are not of the same length, material, or cross-sectional area, the current will tend to flow more through the conductors with lower impedance, which can lead to overloading of those conductors. Secondly, the NEC requires that parallel conductors be terminated in the same manner. This means that the conductor should be terminated using the same type of connectors and that the connectors should be properly torqued. If the terminations are not properly made, the resistance of the connections can increase, which can lead to overheating and potentially failure of the connections. Thirdly, the NEC requires that parallel conductors be grouped together. This helps to reduce the effects of inductive reactance, which can cause the current to be unevenly distributed among the conductors. When conductors are grouped together, the magnetic fields produced by the current flowing through each conductor tend to cancel each other out, which reduces the overall inductive reactance of the circuit. Fourthly, the NEC provides guidelines on the overcurrent protection of parallel conductors. The overcurrent protection devices, such as circuit breakers or fuses, must be sized to protect the conductors from overload and short-circuit conditions. The overcurrent protection devices should be located at the beginning of the parallel conductors and should be sized based on the ampacity of the conductors. Fifthly, the NEC requires that parallel conductors be identified as such. This can be done by labeling the conductors with the word paralleled or by using a color code to indicate that the conductors are part of a parallel set. Identifying parallel conductors helps to prevent confusion and ensures that electricians working on a system understand that the conductors are part of a parallel set. In addition to these specific guidelines, the NEC also provides general requirements for electrical installations that apply to parallel conductor systems. These requirements include proper grounding, bonding, and wiring methods. Grounding is the process of connecting the electrical system to the earth, which helps to protect against electrical shock. Bonding is the process of connecting all of the metal parts of the electrical system together, which helps to create a low impedance path for fault currents. Wiring methods refer to the way in which the conductors are installed, such as in conduit, cable trays, or direct burial. Now let's address the question of whether an arrangement with 4 runs of 4-conductor 240 armored cable where 3 conductors from each cable are used to comprise a phase is permitted. As previously discussed, this arrangement is not permitted by the NEC because it violates the rule that conductors from different cables cannot be used to create a single phase. The NEC requires that each phase be comprised of conductors from a single cable or circuit. In this case, the alternative would be to use a single cable with 4 conductors to create each phase. This would involve connecting all 4 conductors in parallel for each phase, ensuring that the combined ampacity of the 4 conductors is sufficient to carry the required current. It is important to note that even with this alternative arrangement, the ampacity limitations of NEC Article 310.14 still apply. The combined ampacity of the 4 parallel conductors must not exceed the ampacity of a single conductor that could handle the load without paralleling. In summary, paralleling conductors is a complex topic with numerous considerations. The NEC provides detailed guidance on the requirements for paralleling, including limitations on ampacity, restrictions on mixing conductors from different cables, and specific guidelines on how to size and install parallel conductors. It is essential to consult the NEC and other relevant standards to ensure that all applicable requirements are met. It is also important to consider other factors, such as voltage drop and physical constraints, to ensure that the paralleling arrangement is safe, reliable, and practical.